The zeta potential in particular is a very interesting quantity that can be measured. It turns out that the zeta potential is related to the surface charge, or can be related to the surface charge density. So what we know is that the potential itself is related to the surface charge density, or at least the gradient of the potential. But now we actually know the form of that potential, and if we write it out using our solution, we can identify that the zeta potential is related to the charge density itself via some other terms that include the Debye screening length. Do some rearranging, you can get an explicit formula for the zeta potential in terms of the surface charge density and the Debye screening length. And the only thing that I would remind you of here is that the equation that I'm writing here is technically only valid if the potential itself is small compared to kBt. Everything that appears inside the zeta potential formula that's written there is known a priori, except for the surface charge density. But since the zeta potential itself can be measured, because it's basically like a voltage measurement, you can actually use the measurement of the zeta potential to calculate the surface charge density, which is, I think, how it's used more commonly in practice.